What up, people? It's a new day. My leg's starting to feel a little better. I mean, granted, I literally haven't done anything for like 2 weeks at this point because of my leg, but it's feeling better. It's like the steroids are working, but they cause insomnia, and I definitely had the insomnia. I couldn't sleep. Okay, so we're picking up where we left off yesterday, and we fixed our branches. We got everything nice and neat. It was actually really needed, and it's really cool to get that fixed. And now we're operating from 2 branches, a new feature branch and a main branch. Right now, the new feature branch is not stable. The main branch is stable and includes multiprocessing for multiple client support. But the new feature branch, we're implementing the save system currently. So yeah, that's gonna be next as far as feature wise, but there's a couple more things I wanted to do before we actually work on that, I think. So first of all, our extensions are good. Always check that. Let me see if there's anything I can get rid of here as far as the files, like this empty save file. I don't know if we actually use that anymore, so I'll just delete it. If it's still used, it will get recreated whenever we run the game, so it's no big deal. I know we have a lot of like testing files that I guess I'll keep all my test files. Yeah, I'll keep all my test files. Notes, we haven't really updated notes in a while. And there's a lot of like stuff in these notes that we could just get rid of, but that's not really necessary. I don't want to go like that deep, you know. That's like wiping the baseboards down before we finish doing the floor. Let's finish doing the floor first. So, we need some gum. Alright, so we got anything else we can delete here? Canasta text version. Like, I don't even know. This is just a folder. There's not even anything in the folder. That was like, yeah, that was the text version of the game. That was before we converted it even to a 2D game. So we're just gonna, we'll delete that. Alright, so I think that's pretty much all we can do as far as cleaning up our directory. That's as clean as it's gonna get. I guess I can go through notes just real quick, just see. check the audio, because I know my audio is jacked up. Let me check the audio. There it goes. Alright, it's working. Cool. Okay, so now let's go to things to do. I'm not worried about this node shit. I'm not messing with it. Being extra. Okay. Current issues. Let's look here. We got finish client refactor save. Get this file instead of running save. Okay, so that actually is the next thing to do. So let's go ahead and work on that. I forgot to set my timer. Let's see. We're just gonna do 1 hour. We're already a few minutes in. We're 6 minutes in, so we'll do 62 minutes. There we go. All right, timer set. And let's see what we can get done. Let's go over here to client. This is actually client by. All right, so let's open it up. Separate it in its own little group, tab group, I guess you call it. Okay, so currently, this is going to be a hard part. This is not going to be easy. So let's start at the top here. We have our while true. This is our outer loop for the menu screen, which we actually don't have implemented yet. This is kind of like a placeholder for the menu screen, though. And what we do is we check to see if there was a soft disconnect. If it was false, we create this database file if it doesn't exist. The isolation level, I forget what that does. That it's necessary for a reason, but I can't remember why. It has something to do with like auto committing or auto auto commit or something. Let's ask ChatGPT because I just want to be refreshed on that. SQLite setting the isolation level you can done in the SQLite 3 module means that auto commit mode is enabled. Yeah, so it does enable auto commit. So as you execute SQL commands outside of an explicit transaction, they will take effect immediately. You don't need any call commit. So let's all right. That's cool. Okay, so then we create a cursor. We start this. We set up some settings for the database to make it run faster, which is very important. Like, we tested all this. All this has been double, triple check. I don't need to go through all this. I'm pretty sure we tested client ID and game ID. Almost certainly did. Yeah, we definitely tested that already. Inserting the save data. What are we doing here? So this is for reconnect. So if we start a new game versus reconnect, okay. Now, an overall question that I had about, see all this code that's like this peach color? That is all code associated with the database and the save system. And as I was going through this file, looking at all the different things that we're going to need to save, and there's a lot of them, it's become a question of whether or not I should add all of the database save system code inside of this thread, or if I should create an entirely separate thread that has all of the save code, so that basically the save code will be separated visually from the base client file code, so that we don't, it's like basically would double the amount of lines in this file if we just were to add all of the database save code into this thread. It would cause a lot of extra things to be extra lines to be added, like a lot. For instance, like all of this, basically current client ID, that would need to be saved. This would need to be saved. There's a lot of, like, well, you could say that we would just have to save certain, like, we don't have to save every single data point. We don't have to save every single thing, because some things we could just like run again. Like, if, as long as we save the client ID, for instance, if we save the client ID, we could just basically rerun this section of code on reconnect, and then we would check the client ID, and if the client ID was 1, then we would assign all this stuff. Don't need to hear C above, removing this line. Yeah, we're removing C above section comment. Let's see. This is runs the beginning of the game started every probably inside a function called function. I don't see this comment here associated with what I was talking about, removing these 2 lines. This is the exact same code that runs at the beginning of a new game start, therefore we should probably put it inside of a function and call the function to reduce line usage. It is 100% copy and paste. Actually, it's not a 100% copy and paste. In this section, we remove 2 lines. Okay, there we go. Current game state, waiting other player to join the server. since this client is the one that is reconnecting, therefore it's actually the other player that's waiting for us. Okay. Gotcha. True. That makes sense. So let's get rid of that. But yeah, like I was saying, as long as we save client 1, this stuff would get set after the fact. Based on that data. We wouldn't need to have all the other stuff get saved. So, with that in mind, it wouldn't overload the file. It wouldn't clutter it as much if we did it like that. But a part of me, so here's what I'm debating right now, is there's 2 design philosophies. Is one of them is just inline, same thread like we have right now. So if you look at this section, there's a good bit of database operations mingled in here. It's not like overcrowding it, but you know, there's a good bit of database operations here. Like all this is database stuff. So right here, we're choosing to reconnect to the game. We're getting the object names, the client ID, the game ID, local or remote, and then we're grabbing them from the database because we're choosing to reconnect, so we're going to get that reconnect data. Theoretically, this could be done in another in the other thread. Like we could create a save thread that would handle this. In this thread, the only thing that would really exist would be the player making his choice. So it would just be this line, and then this line, and then this little section right here. Which, as you can see, it would be it's a lot easier to keep track of what's going on in the game without the database code. Adding the database code, it just really gums up the visual of this file. And the reason that I'm talking about this so much and thinking about it is because I don't know if I want to add this do a line-by-line mingling in the same thread like I do at this top section. I don't know if I want to do that for the rest of this whole file. How many lines is it total? Let's see, from 429. Let's see, 429. Let's say minus 10 lines, so let's say 439 minus another 10, so let's say 449. Let's say 449 You see all this code? This is a lot of code. Say another 10 lines, 459. So that's it. Okay. So from 459 to 703. How many lines is that? That's 245 lines. So I would say that would probably end up adding about, let's say, between 30 and 50% of that amount to this file. So we're looking at let's just say 250, and let's say half of that is what, 125. So you're adding another 125 lines to this file. That's not crazy. Like, it's a lot. It's not so much the addition of the lines, it's the fact that they have to be mingled in. Does that make sense? That they have to be mingled in. That's the real bother. I mean, we could do it. I could do it like that. It's just let me put this. Single thread mingled save option roughly 250 lines to go through and add in DB operations. Estimate that 30 to 50% would be added for this, aka added 125 lines mingled in. And then the other option would be the double threaded save option, and this would require us to go, we'd have to go line by line either way, but this one would require us to we would have to create like a master list of all changed, like of all the data points. You know, we would have to create like a list or a dictionary with all these different namespaces: sent data storage dict, send ID, current client dot c1 to c1 send ID. All this stuff would have to be saved. Like it would have to be part of this list. Pre-serialized data, message head, but I guess if we use the checkpoint option, but the checkpoint doesn't, the checkpoint is for reconnecting. The checkpoint doesn't actually solve the problem of, checkpoint doesn't have anything to do with like what we have to save, because man, this is just hard. This is so much of a big feature to add. It's really, it's difficult, man. Thinking about it, it's stressful. There's a lot of different things to consider. I don't necessarily know if doing the multi-threaded option would be easier. But the multi-threaded option, basically what we would do is we would create this master data point list, and it would have just all of the different namespaces like message head, data, pre-serialized data, sent data storage dict, send ID, current client, C2 to C2 send ID. All this stuff would need to be saved. And the save thread would just constantly iterate through this list, checking to see if anything had been changed. And if anything was changed, it would just update the value associated with that namespace. You know, using just like a dictionary. And then every time we detected a change, we would overwrite that namespace with the new data, and then we would write that new data to the database. And I feel like that's not so hard in like when I say it like that. It doesn't sound that difficult, but I feel like it's a little bit more. Is it more complicated than that though? I feel like my concern is if we do it this way, well, I think that my concern is not really valid, right? Because if we have data that gets set and it hasn't been changed yet, it's safe. to have it assigned as whatever it was last assigned to. My concern is like saving something and then reconnecting, and then when we reconnect, like reapplying that data errantly. But when we use that in tandem with the multi-threaded system, I think it would cause us to not have to necessarily reapply every single data point that we saved, only the ones that we needed based on the checkpoint logic, if that makes sense. You know, so if we like disconnected at this section and then we went to go reconnect, we would have our checkpoint number registered and we would only reapply, you know, this data. Granted, everything else would have been saved, but we would just reapply a subset of the saved data. And then we would basically just I mean, we would figure out a way to flush out the bad, like, data. Well, it's not necessarily bad. It wouldn't be bad. It would still be good data. It's just not needed. And once we, like, overrode it with once we went through the while loop again and overrode that namespace, it would basically always be a correct reflection of what should be applied in the case of a disconnect. That's my concern. And now that I talked through that, I think it would be safe. I'm leaning towards doing that multi-threaded option that I just said, because I mean, it's definitely going to be less performant. There is that. It's not going to be as performative, but I think it might be worth it. And then let's just say if performance is an issue, we could always revert to the inline mingling, which would definitely be more performant, but also would be a nightmare to read and to debug. I don't want to say it would necessarily be a nightmare, but it wouldn't be very fun, that's for sure. It wouldn't be as clean as the multi-threaded option by a long shot. It would be totally different to look at. So yeah, I think I made my decision. I think what I'm gonna do is I'm gonna do the multi-threaded option. You know, it's really not that many data points. I would say we're looking at probably, I would say about between 20 and 50 data points. Probably if I had to guess, I'd say about let's say about 35, 40 different data points. Let's say about 35. So let's write this down. Requires creation of let's call it master data point list, which consists of requires creation of master data point list, which consists of all main thread data points that would need to be saved. Doesn't necessarily mean we would need to save every single data point, but we could do that, and it might be smarter, because if we saved every single one, it's a trade-off. Like if we saved every single one, then whenever we reconnected, we wouldn't have to like intelligently determine what code needs to be run. You know what I mean? We would just basically reapply all the data that was saved one to one, and then like reassign all the namespaces to the associated values, and then we would have to intelligently determine where to pick back up in the while loop. But there is another option concerning that. Whenever we were to integrate back into the while loop, we could always start at the beginning of the while loop and work that way. But personally, I think the idea of using the checkpoint system seems better. I mean, I could be wrong, you know. We could say that each iteration of the while loop could be a checkpoint. But that's basically the same thing as saying that's basically saying don't use a checkpoint. You would just start at the beginning, and work your way down, and you would always reapply certain data. Yeah, I feel like we should do multi-threaded, and I think we should do checkpointing based off of like what section we are in the main while loop, i.e. we would have our like filter section. This would be a checkpoint, and then the beginning of the receive section would be another checkpoint. But you see, that could be. I'm just thinking about whether or not that would conflict. The save data would conflict with that method, like checkpoint for reconnects. Because if we did, let's say our checkpoint was here at the beginning of the receive section. Now, whenever we go to reconnect at the beginning of the receive section, let's say when we actually were running the game, we hit this checkpoint and we got all the way to like right here. So that means all this data would have got saved down here, and it would be in the database. And then whenever we would go to reapply the data, if we use the just reapply everything approach, that means whenever we reconnected, we would assign receive data, sender ID, send ID based on, you know, what had already been received and saved, but we would like rerun the code starting here. And that would be problematic, right? Because we would have code that was like data that was received, and saved, but then like we would rerun this, and it would get overwritten before it got applied. Does that make sense? So like the saved sender ID, send ID, and core data would get thrown away. It would disappear. And that's not good. Unless like we put the checkpoint at a different spot. You know, we could put the checkpoint at a different spot. Yeah, if we put the checkpoint like after, if we put it down here, then that would be, I don't know if that would be better. Yeah, I think that would probably be better. So all these systems have to work together. That's the point. And I don't want to just start implementing. There's like 2 or 3 different systems we're talking about here. We're talking about the actual saving mechanism, the reconnect logic for like what code in the main thread gets run, i.e. the checkpoint system, and then we're also talking about the reconnect save data application whenever we reconnect. So there's those 3 different things. The checkpointing in the main thread locations, the reapplication of data that was already saved upon reconnect, and the actual save thread process. And all those 3 have to work together, you know, like an engine. They have to all match. They can't be out of sync, you know, or it's just gonna ruin. It's gonna be a nightmare. Like, it has to be done correctly. It can't be almost perfect. It has to be perfect. And I don't want to just throw some shit up there and then, like, you know, then I have to realize, oh, this isn't gonna work. I gotta redo the whole thing. And then I gotta like go through with a scalpel and surgically remove the bad code that I added or whatever. Or maybe the code was good, but it wasn't good enough to do what I needed it to do. Or it wouldn't work with the system that I ended up choosing for checkpoint or whatever. So let me write this down, because that's kind of important. So we have our double-threaded save option requires creation of master data point list. It consists of all main thread data points that need to be saved. Doesn't necessarily mean we need every single data point. We could do that, and it might be smarter. Could say saving everything would be smart. It would be safe, I believe. And then there's the consideration, 3 different systems interacting must be perfect. One is the actual save mechanism. The second is the checkpoint reconnect locations / logic, and then the third is the reconnect data reapplication logic. So this refers to how data actually gets saved. And this would be a save thread. And then checkpoint reconnect locations logic is where each checkpoint in main thread is located. And then reconnect data application logic would be reapplication logic would be determining which data to apply from DB upon reconnect, and also determining where in main thread to pick back up. Well, that's that. I don't know. That might. Well, I guess that would more properly land in this section versus the checkpoint one. Determining where in main thread to pick back up upon reconnect. Yeah, I guess that would go here. So these things have to be perfect. They have to be. They have to interact with each other. In sync. So let's actually put this. Let's put this up here. Okay, so we have the single-threaded save option and double-threaded. Let's move this up here. Well, actually, let's leave it separate. We'll put this will be save mechanism. And then we'll change this to look a little bit more like that. So save mechanism, this will be called checkpoint locations / logic, and then reconnect data application logic. Alright, so now we have save mechanism, then we have the checkpoint locations logic, and then we have the reconnect data application logic. So we have these three things. Okay. So as far as the checkpoint locations logic, I'm thinking doing the we'll say main thread checkpoint using checkpoint integer, whatever you want to call it. And must be intelligently located to ensure certain data doesn't get thrown away or used twice. Then we have the reconnect data application logic, and this would use checkpoint int to determine which data, which saved data needs to be reapplied. would use checkpoint int to determine which where in main thread to start back up at. Yeah, and I think that's a good system. I mean, in theory, you can only brainstorm so perfectly, right? Like, I'm not a god. I can't visualize exactly how it's going to be, but in general, I think that's a good system to use. Can't you collapse all? There's a shortcut for that, but anyway, it's not that important. I want to make sure this is nice and organized, but what else do I want to add? Okay, so we'd use checkpoint to determine where in main thread to start back up at, and this would be accomplished by like how would that actually be done though? How would we? I mean, whenever we reconnected, we would have this checkpoint integer, but I remember we went over this before, and we couldn't just jump in the middle of a section. We would have to. It might be smarter to make a complete separate set of code well, no, that wouldn't work. I think what we would probably have to do, I think we went through this before. I think what we decided on was that we would have to put these different sections in their own function, you know, to where whenever we reconnected, we would check the reconnect integer and then run whichever section of code we would want to jump back in at, and that code would have to be inside of a function because we couldn't just jump in, like, because of indentations and stuff and like if clauses and all this stuff. You know, it's not that simple as just saying, okay, we're gonna put a checkpoint right here, and then, you know, it doesn't work like that, because then it's gonna check if ready first. It's checking this condition to determine whether it's gonna jump back in there, but we need it to not be conditional. Like, the condition has already been met. You know, the condition has to be the checkpoint integer, not the logic inside of, you know, the main while loop. I'm pretty sure, yeah, I had brainstormed all that. I'm trying to think of where did I put that. Let's see, is it in here? Is it in things to do, or was it in client? Because I definitely wrote a lot of stuff in client. See what I put here. Save point. Trigger var dc during send receive equals receive. Wipe slate clean revert back to the save point state. Don't worry about receive data apply list. That's too much work, requires too much precision. Simply have the other side send last sent data. Check to see if data is saved in receive data storage. If is in receive data storage, add logic to skip the receive data assignment. and use that data in place of it, then begin operation through normal loop as is. Only thing changed was receive data. Same logic for send. Save state. Check DC during var. Revert to save state. For send, this would be prior to draw window main. Redo last input. Normal send loop. There's no way it could just be that easy. Let's read this again. Save point, trigger var, DC during send or receive. So in this system, we would determine whether we were sending or receiving. Yeah, but that would cause, like, wouldn't that cause data loss? Like, maybe not. Sometimes things aren't as complicated as I make them out to be, but sometimes they're more complicated than I think they are. You know, like sometimes I have to be way more precise than I thought I was gonna have to be, and then other times it turns out that it's like, hey, this really isn't that complicated. You know, you could say it's really just a send, receive, draw window loop over and over again. And that is technically true, but I don't know if going about it that broadly would work. Trigger var DC during send receive equals receive. Wipe slate clean. Revert back to this save point state. Don't worry about receive data apply list. Okay. That's too much work, requires too much precision. Simply have other side send last sent data. Check to see if data is saved in receive data storage. If it's in receive data storage, add logic to skip the receive data assignment and use that data in place of it. Then begin operation through normal loop as is. Only thing changed was received data. Same logic for send. I mean, I'm not wrong here though. Like this is actually true. Yeah, you know, I gotta pick a specific thing that I'm gonna do. I think I have looked at it from a bird's eye view enough. I think I should try this simple approach first, because if we can do it this easily, this simple perspective of send, receive, apply data, and then draw the window. It's basically 4 actions. You're receiving, applying, drawing the window, and then sending. If we looked at it from that perspective, that would really make it easy to reapply data. Like that would make it easy to reconnect. That would make the reconnect logic pretty simple. That would mean there's just 4 checkpoints, one for each of those. And in that case, that would really simplify everything, because then we would only need 4 different functions, 4 checkpoints, and that seems, reasonable. Yeah, because as far as like the window being redrawn, if it hasn't, my concern though is like this precision, detail-oriented focus where, let's say the client was in the middle of making a choice of like which wildcard he was going to choose for his meld, and then they disconnected, and now when they reconnect, how do you restore that state perfectly without disrupting, from that simple